Right. Welcome back. I'm Ian Harris. This is I Really Should Know That, the show where adults catch up on the science they should know but never bothered to look up. Today, 10 things you stopped questioning. You probably stopped questioning them when you were about 6. The sky is blue, ice floats, mirrors flip your left and right, yawns are contagious, you can't tickle yourself. Why? One of them, about mirrors, has been wrong in your head your entire life. Mirrors don't actually do what you think they do. We'll get to that. Why is the sky blue? The actual answer is one of the most beautiful bits of physics there is. And most of us forgot it by the end of school. Sunlight looks white, but it's actually every color mixed together. When that light hits Earth's atmosphere, it bounces off the air molecules. This is called scattering. Here's the key bit. Short wavelengths scatter much more than long ones. Blue light has a short wavelength, red light has a long one. So blue gets bounced around the sky in every direction. And that's the color you see when you look up. It's blue light coming at you from every direction at once. Same physics explains why sunsets are red. At sunset, the light is traveling sideways through way more atmosphere. All the blue has already been scattered away. Only the red wavelengths make it through. One mechanism. 2 everyday miracles. Speaking of things you stopped questioning, mirrors don't actually flip left and right. You've been wrong your whole life. Here's why. Why do mirrors flip left and right but not up and down? They don't. Mirrors don't flip left and right at all. Your brain has been lying to you about this since you were a kid. Stand in front of a mirror. Touch your right ear. The reflection touches its ear on the same side as yours, its right ear, from its perspective. The mirror didn't move anything left or right. What the mirror actually flips is front to back. The you facing you in the mirror is what you'd look like if you'd been pulled inside out through the glass. Your nose, which was pointing forwards, is now pointing backwards. The left-right flip is something your brain does. You imagine turning around to face the mirror, and that's the rotation that swaps your sides. The mirror is honest. You're the one doing the flipping. Speaking of things you stopped questioning, ice floats, and that's the only reason life exists. Ice floats. Almost nothing else does this. Almost every other liquid in the universe gets denser when it freezes. Water is the weird one, and it's the reason life exists. When water cools, the molecules pack closer together, like every other liquid. But just before it freezes, something weird happens. The hydrogen bonds force the molecules into a rigid hexagonal lattice with gaps in it. Ice is literally water with empty space built in. It's about 9% less dense than liquid water, so it floats. Now imagine if ice sank. Lakes and oceans would freeze from the bottom up. There'd be no insulating layer of ice on top. The entire water column would freeze solid. Nothing aquatic could survive winter. Every fish, every microbe, every ecosystem in cold water exists because one weird molecular quirk makes ice less dense than water. Life on Earth runs on that detail. Speaking of weird quirks, try to tickle yourself. You can't. And the reason why is genuinely fascinating. Try to tickle yourself. Nothing. 0. But if someone else does the exact same motion, you can't stop laughing. The reason is buried deep in how your brain predicts the future. Every time you move, your brain sends a signal to the cerebellum, a small region at the back of your head. The cerebellum makes a tiny prediction of what that movement will feel like. When the real sensation arrives a fraction of a second later, the cerebellum compares it to the prediction. If they match, you don't really feel it. Your brain effectively cancels out the sensation of your own actions. That's why your own touch doesn't tickle. The brain saw it coming. Someone else tickling you? No prediction, full sensation, with the bonus of surprise. That's what makes it ticklish. The brain hides the predictable so you can pay attention to the unpredictable. Tickling is a glitch in that system. Speaking of glitches in the system, you're about to yawn, just from me saying that. Yawning is contagious. Even reading about it makes you do it. Even thinking about it, why? It might be the most ancient social behavior you have. Around half the people watching this video will yawn in the next minute. The contagion works through seeing it, hearing it, reading the word, or even imagining it. Most likely, this is your mirror neurons firing. These are brain cells that activate both when you do something and when you watch someone else do it. They're the foundation of empathy and learning by imitation. Why yawning specifically? The leading theory is group synchronization. Early humans living in tight groups benefited from sleep schedules aligning. A contagious yawn was a social signal. We're all winding down together. So when you yawn at someone yawning, you're running software that's older than language. That's a small piece of the deep past leaking through. Speaking of things older than language, metal feels colder than wood at the same temperature. They're identical. Why does one feel cold? A wooden bench and a metal bench in the same room are the exact same temperature. Touch them. The metal feels freezing. The wood feels fine. Your fingers are lying to you. You don't actually feel temperature. What your skin detects is heat moving in or out of you. Metal is a brilliant conductor of heat. Touch it, and heat rushes out of your hand into the metal almost instantly. Your skin reads that fast drain as cold. Wood is a terrible conductor. Touch it, and the heat in your fingers stays in your fingers. Your skin reads that absence of drain as warm. The two surfaces are identical in actual temperature. The metal just steals your heat faster. Same reason marble feels colder than a duvet, and water feels colder than air. Conductivity, not temperature. You've never actually felt how hot something is. You've only ever felt how fast it can take heat off you. Speaking of physics that should feel impossible, that cloud above you weighs about 1,000,000 pounds. So why is it just floating there? An average cumulus cloud weighs about 1,000,000 pounds, 500 tons of water, and yet it's just hanging there. It's not falling. Why? Clouds are water, billions of tiny droplets, but each droplet is microscopic, about 1/100th of a millimeter across. That's so small that the air resistance on them is enormous relative to their weight. Falling at terminal velocity, a cloud droplet drops about 1 centimeter per second. It would take days to reach the ground. Add to that, warm air is constantly rising up into clouds from below. That updraft is faster than the droplets fall. So the cloud isn't really suspended. It's a slow motion balance between droplets drifting down and air pushing them back up. When droplets do grow heavy enough, by merging, they overcome the updraft. That's rain. A cloud is 500,000 tons of water, barely losing against the air. Speaking of things that look impossible, that giant moon on the horizon, it's not actually bigger. Your brain is fooling you. When the moon's on the horizon, it looks enormous. When it's high in the sky, it looks normal-sized. They're the same. You can prove it with a single photograph. So why does your brain insist it changes? Take a photo of the moon when it's huge on the horizon. Take another a few hours later when it's high overhead. They're identical. Measure them. The pixels don't lie. The reason your brain sees the horizon moon as bigger is called the moon illusion, and it's been debated for 2,000 years. The leading explanation: when the moon is near the horizon, your brain has reference points, buildings, trees, hills. It assumes anything that big, that far away, must be massive. When the moon is high in the sky, there's nothing nearby to compare it to. Your brain shrinks it. The illusion isn't in the sky, it's in you. Speaking of illusions in your own head, you've walked into a room and forgotten why. Everyone has. There's a reason, and it's the doorway. You've walked into a room and immediately forgotten why you went in there. It's called the doorway effect, and the culprit is the doorway itself. Your brain organizes your day into episodes. It doesn't store experience as a continuous stream. It chunks it into discrete events. Crossing a physical boundary, especially a doorway, is a strong trigger for what psychologists call an event boundary. Your brain decides one chunk has ended and a new one is starting. It mentally files away whatever you were doing, anything that was just sitting in your short-term working memory, including go to the kitchen to get my phone, gets deprioritized. The new chunk needs the space. The fix? Go back to the room you were in, recross the boundary, and the original mental context comes back, usually instantly. You're not losing your mind, you're just being filed. Last one. You've been seeing rainbows your whole life. You've only ever seen half of one. A rainbow is not an arc, it's a full circle. You've only ever seen the top half of one your entire life. The bottom half is below the horizon, and from a plane you can see the whole circle. A rainbow happens when sunlight enters a raindrop, bounces inside, and exits at a specific angle, about 42 degrees from the direction of the sun behind you. Every drop at exactly that angle from your eye, in every direction, sends coloured light back to you. That set of drops forms a complete circle around the anti-solar point, the point directly opposite the sun. The reason you only ever see the top half is the ground. It cuts off the bottom of the circle. There are no raindrops below your feet to complete the arc. Climb in a plane during the right kind of weather, look down, you'll see the full ring. Worth knowing. That's 10. There's an unlimited supply of these. Half of physics is, wait, why does that happen? Series 5. Drop a comment with which you want. How your house actually works, microwaves, fridges, batteries, Wi-Fi, the things you use every hour and couldn't explain on a bet. Or medicine in your medicine cabinet. What aspirin actually does, why caffeine wakes you up, why placebos work even when you know they're placebos. I'm Ian Harris. Cheers.